Okay, well, welcome to today's lesson. We're going to be looking at precipitation and excess runoff in the water cycle. Um, it really is a key process in the water cycle as such that without precipitation, we don't have that movement of water and water moving around the cycle in itself. So the key terms really here is thinking about that as precipitation, and we're really today going to be thinking about the processes that are needed for condensation to happen and the different things that cause rainfall to happen. And so the first thing really is to think about what condensation is. So a very simple definition there is that condensation is the process by which vapor changes into a liquid or a solid form. For this to happen in the atmosphere, a nuclei must be present. So remember that precipitation is not always rainfall. There are different types as well. So it could be hail, it could be snow, it could be sleet, and that's important to remember. Now, with any form of precipitation, it's really focused around this thing we call air uplift. So in order for most precipitation to occur, we need air to be moving up into the atmosphere. And basically the higher you get into the atmosphere, the cooler it gets. So every 100 meters you go up into the atmosphere, the temperature drops by 1 degree C. That's why if you're stood at the top of a mountain, it tends to be much colder than if you stood at the bottom of that. But the reason for that is highlighted in the slide here. So you've got air uplift, which leads to cooling and condensation because we get a fall in pressure. The fall in pressure as you move higher up results in the expansion of air, and that means that the air particles are further apart from each other and you basically get less collision. And when you're not getting that collision occurring, you're not getting the release of heat energy. And I put there heat energy per unit volume, and so that will lead to a fall in air temperature. And as a result of that, you get clouds forming as the water vapor condenses into droplets. Now, there are three main reasons for air to be caused uplift into the atmosphere. And you might have heard of some of these before when you studied things like this or done weather and climate in lower school. So you've got convectional rain, you've got frontal rain, and you've got something called orographic rain. Orographic you might have come across before as being called relief rain, and that means pertaining to height of land. And I'm going to get you to look at these in a lot more detail in the lesson today. I'm just going to talk a little bit about what each of these are. So to start off with, convectional rain is pretty straightforward in terms of this is where you've got convection relating to heat. And so it could be a really simple scenario where on a hot summer's day, the sun is shining down, it causes water to evaporate up into the atmosphere, and it rises up into the atmosphere. As it rises higher, it cools, it condenses, it forms clouds, and then you get rainfall. So here we're looking at what causes the uplift, and within convectional rain, what causes the uplift is heat. Now within frontal rain looks at a different type of uplift, and frontal thinks about air temperature and air masses. And here what you can get is a cold air mass and a warm air mass, and as they move towards each other, the cold air sinks underneath the warm air, and the warm air is forced up into the atmosphere. It causes it to rise upwards. And so the same thing is happening again. It's what's causing this uplift to happen. So you've got a cold front and a warm front. These two air masses, they meet each other and one rises up above the other, and it rises up into the atmosphere. And as it rises up, again it cools, it condenses, and it causes rainfall. And the final one, and this is the one you're probably most familiar with, is orographic rain. Now orographic rain, this is where you've basically got a big hill in the way of something. Now the most famous form of orographic rain in the world is probably the Himalayas. And you get the winds blowing up over India, across the Indian Ocean, they bring water in with them, and you get the monsoon rains pushing upwards. And as they move up over the Himalayas, basically it gets forced up into the atmosphere. It rises up, it cools, it condenses, and it causes rainfall to happen. And the Himalayas are such a barrier to rain that actually behind that you get the Gobi Desert, and so water cannot go that far. That was a bit overly complicated there in my description. Basically, imagine a big hill, and as the air hits that hill, it's forced to rise up over the top of it. And it does the same thing. It causes the air to uplift. It rises up over the hill, it cools, it condenses, and it causes condensation. Now here, this is an excerpt from the textbook, and these are also on Show My Homework. You can see you've got these different types of rainfall. And what I'd like you to do is actually spend half an hour with a subheading for each of these and to draw the diagrams and explain what is happening. On the next slide, there is a little bit more information. Now, obviously, if you want to, you can pause this presentation, or what you can do is go and have a look on Show My Homework and actually get the page of the textbook to have a look at. So the next slide here has just got a bit more explanation about those three main types of rain. And it's really important you know about each of these and can explain them. Remember, in the carbon and water cycle part of your course, you can get asked shorter questions. So there are sort of 5-mark questions, and those might be as simple as explaining a type of rainfall. So it is important you know these in detail. This map here kind of really highlights how orographic rainfall works. So if you have a look at this, it's a map of the UK, and you've got the map on the left, and this shows you the rainfall amounts. And what you'll notice is that the areas that have got the darker blue are the areas that have got the highest rainfall, and the areas that are white are also over 1,000 millimetres of rain a year, which is quite high. And then you've got the areas there that are brown. The brown areas are area where of the UK where the rainfall is lower. Now what you can probably see here is that down the west coast of the UK you've got very high levels of rainfall, and on the eastern side of the UK, especially around the southeast, you've got less rainfall. And this here on map on the right hand side helps us explain why that is. So what you can see is this is showing the relief, so how high land is, and you'll notice that all the way from around in Cornwall up into Wales, and then you've got the Pennines coming up here, and then we move into the mountain ranges in the very northern parts of the UK, so the Lake District, and then up into the Scottish Highlands. And if you compare those two maps with each other and overlay them on top of one each other, you'll see that the rainfall is directly linked into one another. So you can see there that the areas of higher ground have areas of they've got more rainfall. And that's down to two factors. So one is that mainly our weather comes from the southwest, so the winds will blow across the sea and bring that weather in, so it hits this area first. But also it's due to the fact that that land is higher. So the orographic rainfall, the wind's forced upwards, and as they rise, it cools, it condenses, and it causes the rainfall to happen. And so relief is that air uplift in the UK links to the areas that have got the highest amounts of rainfall. Now you need to know about two different theories of precipitation formation. And the first one's got a very fancy name. It's called the Berger and Findeisen process. And the second one's got a more simple name, which is the collision theory. Now I am going to set you a bit of time to have a look at these, but I am going to explain them very briefly. We're going to start off with the Berger and Findeisen process. So the Berger and Findeisen process is based around this idea that all rainfall starts life as ice. So as you go up into the atmosphere, you've got a mixture within clouds of some of ice crystals and also water particles. And this theory is that the water particles are attracted towards those ice particles, and those ice particles get larger and larger and larger until they're too big and too heavy to stay in the atmosphere, and they start dropping downwards. Now, if it's a cold day, then it might drop down to the ground as snow or hail, or if it's a warmer in the atmosphere, you might find that it drops down as rainfall. So as it drops down, it melts and turns into water. Now, if you imagine how high most clouds are in the atmosphere, we're talking about every time you go up 100 meters into the atmosphere, the temperature is dropping by 1 degree C. So you can imagine that if you're going a few hundred meters up into the atmosphere on most days within the UK, it's going to be very cold. if you've ever been in a plane before, you'll know that it's extremely cold on there. So in our atmosphere, it's very cold. And so, especially in the northern hemisphere, they believe that this theory explains how precipitation is formed within northern latitudes. However, there are places in the world where it's very warm, and they believe that that process is slightly different, and this is the collision process. And the collision process is this idea that you have a nuclei. That nuclei might be a bit of salt, it could be a speck of dust, and the idea is that water droplets are attracted to that and they form around that, and then they combine. They basically collide into different water droplets until the droplets get so big that they become too large to be held by the atmosphere, and they fall to the ground. Now, I'd also like you to spend a good, probably half an hour to 45 minutes really looking through the textbook at those two processes and explaining how those two processes work. Now, there are a diagram, especially for the Berger and Finn-Dyson process, which might help for you to draw, but it'd be good to have a read through that and really get some detailed bullet points about how each of those two processes work. The final thing for you to have a look at today is going to be looking at the causes of excess runoff generation. So this is the last part of the work on page 30. And this is really simple, really. It's just thinking about how precipitation can lead to an excess amount of water on land. And so really simply, I'd just like to have a little read through that and then take some notes.